Today we're going to talk about the classification of matter. Matter is anything that has mass or volume or weight minus gravity and takes up space. So in life science, you learned probably about the classification of living organisms. We separate things into animal kingdom, plant kingdom, and then we get more specific. We separate animals into things like mammals and amphibians, all the way down to species. And we do that because it helps us to make sense of what we discover and what we already know. It helps us to see how things function and how they fit together. But you don't have to be a scientist in order to classify things. We do it naturally as humans. We like having things organized. So if you go into someone's house and you're looking for a fork, you're not going to go in the bathroom to find a fork. If you do find a fork in the bathroom, I would suggest that you leave because that's a little bit strange. But you would go in the kitchen and you would open a drawer, and when you find the silverware, even within that drawer, it's going to be separated into knives, forks, and spoons because we like to know where things are and where to put them, and we like to make sense of them. In physical science, we categorize matter. And we're going to use three major categories: elements, compounds, and mixtures, which are here. An element is the first thing that we're going to look at. An element is the basic, most simple form of matter. Elements are organized on the periodic table. They're found in the earth, they're found on the earth, and they're found in the earth's atmosphere. Everything that we come into contact with is made up of those elements. Elements cannot be broken down into some other substance. The smallest part of an element is actually an atom. So here, we're going to call this our carbon atom. If you have one single atom, it's going to be of one specific element. So carbon is here. This is going to be our chlorine atom. This will be hydrogen, sodium, oxygen. Those are the ones that we're going to take a look at today. So when you have an atom and you know that it's of a specific element, you can recognize that either by its name and knowing that it's on the periodic table, but oftentimes in chemistry, you're going to see that it's written as a symbol. They have shortened abbreviations for their names. So for instance, carbon is represented by a capital C. Hydrogen is represented by a capital H. Oxygen is O. Chlorine is Cl. Sodium is actually Na, and that doesn't look like it makes much sense because the others match the names, but that's because the element names actually come from Latin and they don't always match up with our English words. So notice that these two have a lowercase letter. There's always going to be a lowercase letter in the second spot, never a capital. So that's how you can determine if something is an element. But a compound is a little bit different. A compound sounds like what it is. It's when you put things together. So if you have two or more elements that actually combine to make a new or a different substance, that's when we have a compound. So chlorine, for instance, is a green toxic gas. It's dangerous for us. You can't inhale chlorine safely. It will kill you. Sodium is a white, soft metal, and if you place it in water, it explodes. Also dangerous for us. Both of those are extremely dangerous for humans. However, if you take these two atoms, the chlorine and the sodium, and they're in a space together and they have enough energy to combine and stick together, they change what they are, and they become something called sodium chloride, also known as salt. And salt is actually something that humans need. So that is a compound. It changes when they combine, but it has to be a chemical combination. The same thing is true when you have oxygen and hydrogen in the same place. If they move around enough and they have enough energy, it's called activation energy, they will stick together and create a molecule. So hydrogen at room temperature is a gas. Oxygen is a gas, but when you put them together with two hydrogens and one oxygen, you get H2O, two hydrogens, one oxygen, and that's water, or dihydrogen monoxide, which sounds a whole lot scarier than water. We can also take a look at something that is scary. So we have carbon. Carbon is what makes up a lot of us, carbon-based life forms. We have carbon and we have oxygen. Oxygen is something we absolutely positively have to have. It gets in our blood and it oxygenates our entire body. But if these two things combine, you end up with something called carbon monoxide. And that's dangerous. In fact, in your home, you probably have a smoke detector that will not only detect smoke, but carbon monoxide, because it comes from things like propane or natural gas. And we can't inhale it, it kills us. So if you see a compound, sometimes it's written out like carbon monoxide or carbon dioxide, sodium chloride, but sometimes it's written as a formula, and that's how we can recognize a difference in writing between elements and compounds. A compound, instead of having one symbol, will have a combination of things, and it shows us the ratio of atoms of one element to another. So water is the easiest, and we already know that. It's H2O, 2 hydrogens, 1 oxygen, because there's no number there. This is a compound. Carbon monoxide looks like this: 1 carbon, 1 oxygen. Notice though that the capital O is capitalized so that you don't get it confused with the symbol for cobalt. We also have things like H2O2. H2O2 looks a lot like H2O, but it's not the same thing at all. It has an extra atom of oxygen, and that makes it hydrogen peroxide, and you can drink it and it won't kill you, but it will make you vomit until everything is out of your stomach. So you don't want to do that. And then we also have something that we talked about already. Sodium chloride, or salt, is 1 sodium atom and 1 chlorine atom. Those are all examples of compounds, and sometimes you'll have more than 2 elements in a compound. But typically these are things that we're going to be looking at in science. The last thing that we're going to take a look at is a mixture. And a mixture is when 2 or more substances are in the same space, but they can actually be separated because they haven't combined and formed some sort of new substance. So we're going to look at salt, or sodium chloride. This is our compound that has an atom of sodium and an atom of chlorine. We know that this is a compound because it has 2 elements and they're combined to make a new substance, which is salt. We're going to place it in our container. We're going to pretend like it's salt. And then we're going to take our water, our H2O, and we're going to place that in here, and we're going to pretend like there's a whole bunch of both of them, and we mix them together and you end up with salt water. The salt is still salt, it's dissolved in the water, and the water is still water, it just now has salt mixed in. So we can separate that. We can evaporate the water and the salt will be left behind. That's what makes it a mixture. It's not a new substance, it's just 2 things in the same place. Other examples are things like coffee or chocolate milk. Cereal and milk is another good example. If you take 2 metals and you mix them together, that's called an alloy, but really it's a mixture. And metals all have different melting points, so you can melt one metal while the other one stays in solid form and separate those 2 as well. They don't make a new substance, it's just a mixture. So now you should be able to determine the difference between an element, a compound, and a mixture. Hopefully that helps.